Hello, here we're going to be talking about scatterplots. Scatterplots are a really important way of visualizing data when you have bivariate data, and what that means is that you've taken two measurements of two different things on each individual or each sample that you're measuring. Scatterplots are a really important thing to look at when you've got bivariate data and you're just starting your analysis of the data, you're starting your exploratory analysis, and they're important to look at early on in your analysis because they can tell you important things that you need to know that will inform what you do in the rest of your statistical analysis of your data. So if you look at scatterplots, you can find out all kinds of important things. If there's a relationship between one variable and another, so if there is a correlation between them, then you'll probably be able to see that in the scatterplot. And also, if there are other things about the data that are important, you may well be able to see it in the scatterplot. So if there is structure in the data, if there is particular clustering, if there is curvature in the relationship, if the variance is changing across the value of the variables, and if there are serious anomalous data points, you'll be able to see all of those in your scatterplot. So looking at scatterplots is a really important thing to do early on in your data analysis. So very briefly, we're going to look at how to plot a scatterplot. Lots of you probably already know this, but it doesn't do any harm to just have a recap. Let's say you've been doing an ecological study and you've been looking at nitrate content and you've been looking at zooplankton diversity in some ponds. So you've taken a water sample from each pond, you've counted the number of species of zooplankton in that water sample, and you've analysed the water for the nitrogen content in milligrams per litre. So here are your data. You've measured these things for 6 different ponds, and what you can see is that these are what we call bivariate data. There are 2 measurements for each pond, and now you want to know if there's a relationship between the nitrate content and the zooplankton diversity in the pond. So let's start by drawing a couple of axes, and then we're going to label our axes. When we draw a scatter plot, traditionally people put the variable that might be affecting the other variable on the x-axis. So if you know there's a direction of causality, or if there can only be a direction of causality in one way, then you put the variable that's causing the effect on the x-axis. In this case, it's likely that nitrate is affecting zooplankton diversity, and it's unlikely that zooplankton diversity will be causing the nitrate content in the pond. So we're going to put the nitrate content on the x-axis, and we're going to put the zooplankton diversity on the y-axis. And then we can start plotting our data points. So our first data point has 3.2 milligrams per litre of nitrate and 2 zooplankton species in our sample. So we can plot it here. Our second data point has much less nitrate, 0.4 milligrams per litre, and twice the amount of species. It's got 4 species, so we can plot it here. Our next data point goes here, and then we can draw the rest of the data points in like this. So now we've got our scatter plot, and you can just look at that and you can see that there are some important patterns going on here. First of all, it looks like for low values of nitrate at least, increasing the amount of nitrate in the water is associated with an increase in the number of zooplankton species in the sample. We don't know if the nitrate is causing the number of zooplankton species, but it certainly seems to be associated with it in some way. When we have a high value of nitrate though, we've only got one data point, but that one data point has the lowest species diversity of all. So it could possibly be that we're actually looking at a curved relationship here and we've just missed out some of the middle values, or it could be that that value there is somehow wrong. If you were doing this, you'd probably suspect a curved relationship because that fits with what we know about nitrate in water bodies, that up to a certain point nitrate is good and leads to an increase in the health, if you can call it that, of the water body. But at high levels, nitrate causes all kinds of problems and can lead to eutrophication and a loss of biodiversity. So just by drawing the scatter plot, we can see what the important patterns in this particular made-up data set are. What we're going to do now is we're just going to look at some of the other kinds of patterns that you can sometimes see in scatter plots so that you've seen them, and when you come across them again, you'll hopefully know what they are. So here are some data These are data that were generated with a random number generator with a particular pattern applied to it in R. But these data show some patterns that we can see. So if you look at the plot on the far left, what you can see there is that you have high values of variable 1 associated with low values of variable 2, or alternatively, low values of variable 1 are associated with high values of variable 2. And so we would say that there is a correlation here, and we would say there is a negative correlation because of the direction that it's going in. And this is a pretty strong negative correlation, at least if you're working in biology. You'd be quite impressed if you generated a correlation like that in the kind of field that I work in, at least. You can see it's a strong correlation. There's not a huge amount of scatter around that declining slope of that group of data, and you can see that in the sort of the corners where you would expect high values of both or low values of both, there's no data points there at all. So that's a strong negative correlation. The next plot shows a weaker negative correlation. There's a bit more scatter in the data. The pattern's not as strong and obvious, but you can still see it there quite clearly. If you look at the third plot, you can't really see much of a correlation at all. Although people are very good at spotting patterns a lot of the time, people are actually quite bad at spotting weak correlations in scatter plots like this. I wouldn't look at a scatter plot like that and say there's definitely no correlation there. I'd want to go on and do some kind of analysis to find out. But certainly just by looking at that, you know that if there is a correlation, it's going to be a pretty weak one. It's not easy to see much of a pattern in those data at all. Okay, here are some more data. Most of these have positive correlation rather than negative correlation. So if you look at our top left example, this is a strong positive correlation, much like the strong negative correlation we saw before. High values of variable 1 are now associated with high values of variable 2 and vice versa. And once again, in the areas where you would expect low values of variable 2 associated with high values of variable 1 or vice versa, there's no data there at all. So that's a strong positive correlation. Next up we have another positive correlation, but it's rather weaker. You can see that the pattern in the data is not as clear as it was in the first plot. And in the top right hand plot we've got another positive correlation, although it's rather weaker. You can still see it there, but it's a weak positive correlation. Nonetheless, if you were to do some kind of correlation analysis on this, I'm pretty sure that that would come out as having a significant positive correlation in those data. Moving on to the bottom left graph, this graph shows another positive correlation, but there's something else going on here as well. If you look at the bottom left of the graph, you can see that the data are very tightly clustered together. But if you look at the top right of the graph, you can see there's a lot more spread, a lot more dispersion in those data. And in fact, we've almost got this kind of fan shape going on in the data set here. And what this is telling us is that as the value of variable 1 increases, so the variance in variable 2 is increasing. So this graph is showing us increasing variance in variable 2 associated with increasing values of variable 1. That's a very common pattern in biological data. And if you see it, that has some quite important effects on the kind of analysis that you're able to do. So you need to be able to spot that sort of thing. The next plot shows another positive correlation, but this time it's not a straight line. This time it's a curved relationship between the two variables. And again, when you've got a curved relationship, that's going to have an important effect on the kind of analysis that you're able to do. And then finally, we've got this graph here. If you look at that graph, you really can't see any pattern at all. I can't see any pattern at all in that graph. It's quite probable that there's no relationship between variable 1 and variable 2. But again, we might want to do a formal correlation analysis just to check that. And then finally, we've got two graphs where we're going to look at clustering in the graph that shows you that there's some kind of structure in the data. On the left hand side, we've got two different groups in the data set. We don't know what those groups are, but one of them has a positive correlation between variable 1 and variable 2, and the other one doesn't seem to have the same sort of relationship. So there's something going on in the data, and we might want to look at that and see if there's anything different between the data points in these two groups to try and understand what sort of pattern we're looking at. And then finally, I've put in some real data just to show you that you do actually see this kind of thing. These are data from a paper by Cook and Bean that was published in Animal Behaviour in 2006. And these data are mandible measurements for male fig wasps. These male fig wasps fight with other male fig wasps inside the fig to acquire matings. And you can see that we've got a measurement for body size, which is actually head width, on the x-axis, and we've got a measurement for mandible length on the y-axis. And if you look at this scatter plot, you can see that there are two groups in the data. We've got one group of fig wasp males that have large mandibles for their body size, and then we have another group of males that have rather smaller mandibles for their body size. And it's very likely that this difference reflects difference in the actual behaviour of the animals. So what we've got is one morph of fig wasps, which the authors called an aggressive morph, and they suggested that this morph is likely to engage more in lethal combat with other fig wasps. And then we've got another morph that they call a passive morph, and this morph is more likely to use other strategies to try and acquire matings. So maybe it sneaks around and tries to acquire matings, or maybe it just tries to move faster than the ones with the big mandibles and get to the females before they do. So when you see this kind of structure in the data, that can tell you interesting and important things about what might actually be going on in your data set, assuming you find fights between fig wasps interesting in the same way that I do. Okay, thank you very much.